You guys, this is going to be our unit 7.5, and we're going to be talking about factoring out our polynomials. We learned how to distribute, and so you would take that first number and go ahead and multiply it by everything on the inside of the parenthesis. So this would, for example, be 3a squared plus 7a. Right? Now we're going to learn how to take it back out when we're going to be factoring. So let's just say, for example, we have one like this. We have 4a squared plus 8a. So this would be, instead of the final product when you're distributing, we are going to put it back into the factored form that we originally had. And the way you do that is by looking at both of our terms and saying, what is the largest, what do they both have in common? Okay, so if I look at this 4 and I look at this 8, if I'm factoring 4 and 8, the greatest common factor that they both have is 4. So I'm going to take my 4 out first. And if I take a 4 out of my 4a, I'm left with now just a, right? Because 4 divided by 4 is 1. So I'm left with 1a. But something else can also be taken out. If we look at both of these terms, they also both share the letter a. So I'm actually going to take that out as well. So think about it as we're taking them out, right? We're taking it out. So if I take 4a out of this right here, what am I left with? This is what's going to be left inside the parenthesis, right? I'm actually left with 1a. Since has 2a and we only took 1a out, I'm left with the other a left behind. Okay, same thing here. If I look at this, if I took out a 4, then I'm left with a 2. If I take out an a, then the a is now canceled out. So now I have plus 2. So this would be the factored form of the the form that was originally distributed. Okay. And we're going to talk about how to do that in the steps in just a minute if you didn't catch it when I just talked about it. So don't worry too much. Polynomials that cannot be factored are called prime. So there are going to be some that you're going to look at and you're like, man, these don't have anything in common. I can't take anything out, and that's okay. It's just because it's prime. There are several factoring methods. The approach depends on the polynomial. We start by identifying and factoring the greatest common factor. Just set that, right? The greatest common factor of the polynomial. All right. Identify the greatest common factor. So we're going to check the coefficients, then look at the variables. Divide each term by the greatest common factor and leave the remaining factors in the parentheses. Check your work by distributing. All right. So it tells us right here, find the GCF of the polynomial. And the way we do that is by first looking at our coefficients, then look at the variables. If I look at my coefficients, I have 3 and 12. And I can see that I can take a 3 out of my 3, and I could take a 3 out of my 12. Well, if I pull that out, what is left behind? Well, I'm left with an x in this case. When I'm looking at this first term, I'm left behind. I left that x behind. And then if I take a 3 out of the 12, I'm left with a 4. And of course, I can check my work like it says by distributing. So I'm going to distribute my 3 times my x and my 3 times my 4. 3 times x is going to be 3x. 3 times 4 is going to be 12. And that is the original question. So that is correct. Let's look at this one right here, where we see that there are 2 different variables. Oh, and we're going to look at the coefficients first. So what can I take out of both a 5 and a 30? Well, I can take out a 5. If I look at my variables, I can take an x out of here, but I can't take an x out of here. I can take a y out of here, but I can't take it out of here. So they do not share the x or the y. So in that case, we're going to leave those behind. So since I took a 5 out of the first term, I'm left with my x. Since I took a 5 out of this term, I am left with a 6, right? 5 times 6 is 30. And then I'm also left behind the y. And then of course we can check by redistributing. 5 times x is 5x plus 30y. That does in fact match our original problem, so it is done.